into the Blackboard course page menu, and again you have Alex, so you just like click on Alex, and then click on McGraw-Hill campus, and then followed by clicking on Alex, and it will take you to the Alex Math 171 course page. And now, and just looking at what we have present now for the Alex homeworks, okay, they'll be listed as homework. Okay, so you had the first set, which is now available, which was initiated yesterday morning, and will be due on the evening of Tuesday, June the 20th. And this is with section R4 and factoring. And anything that is listed as homework, okay, those items will be mandatory. So this is just a listing of the semester-long Alex homework assignments. And there were some of you who had inquired about some of the stuff that was listed as being due on May the 6th. And this is just objective stuff, and this is not mandatory. The sets of exercises are optional, and those are in reference to the Pi progress. And again, accessing and working on them, they're optional, but they are not for a grade. Okay, but so anything that's listed as objective but not homework, those are optional, but anything that's listed as homework will be mandatory. And I just want to mention just some things if you're still becoming acquainted with Alex. I'll just give you sort of a quick overview. Say if you're looking at Alex for the first time, it's going to take you to a tutorial page. Okay, have it, and gives you an introduction. Welcome to Alex. And in terms of getting started, you have like your main menu. Okay, those would be the 3 bars in the upper left-hand section. Notifications, what to do next, and if you're to get started, this is just giving suggestions in terms of how to operate with the keyboard as well as its calculator, and how to go about graphing. And I'm just going to skip the tutorial, and once you get through with the tutorial, now since I am the instructor, I'm able to skip around, and once you complete the tutorial, I have congratulations, whatever your name is, to come after, and it will say that you've completed the Alex tools tutorial. And once you continue, you're going to be taken to the initial knowledge check. Now these are challenging exercises, and you're not expected to have a mastery. In fact, the initial knowledge check is just a diagnostic, kind of giving you not to measure what you need to know, but just kind of give you a little preview in terms of the various types of items we'll be looking into. And again, this is not for a grade. You're not supposed to do well on it, especially if you're looking at taking pre-calculus for the first time, and you have just like starting the initial knowledge check. Again, not for a grade, but you have to go through it before you can start on the homework. And there will be about 30 questions. You have various items, and if you were to start the knowledge check, have like a first question like writing in terms of a single variable among possible exercises. And again, be about 30 of these items. And again, you're not supposed to master those. So I'm just going to skip the knowledge check just to kind of give you an idea of what the setup is going to look like. And now, so after going through the round of the initial knowledge check, again, it's kind of like an initiation process. And now, once you get through with that, okay, again, the main menu is going to be where we have the 3 bars situated, and you click on this and you have these various menu items, and where you're going to find the homework, that's going to be over in the assignments section. And clicking on this, okay, so going after working with the initial knowledge check, okay, have current. Okay, you have where it says type homework. Okay, this is going to be your Alex homework assignment. Again, the due date is Tuesday, January the 20th at 11:59 p.m. And to access, okay, have Alex homework section R4 in factoring. Now, unlike the test, okay, you can start and stop. So you have starting out. It says navigate from one problem to the next. And say if you're in the middle of doing something and say, you know what, I don't feel like factoring a sum of cubes. I'd rather go to, let's try another problem where you might have looking at combining ratios that have the same denominator. Okay, and so you're about to work on this and then something comes up and you cannot finish in one sitting. Well, do not worry about that, because what you can do is that you can save this assignment for later and then just re-access at a more convenient time. And I do want to mention, okay, now for the attempts, you have one unlimited attempts. Okay, so until the deadline, you can take this homework repeatedly, as many times as you would like, until the deadline. And I will mention that for what we have regarding the assignments, the way this is going to be set up, we have the section R4 and factoring, as well as other Alex homeworks. Okay, now we have 10 problems in the mix, and now for the Alex homeworks, you'll be able to access the ebook, an example, explanation, and let's say that if you attempt one time and you get like half of them correct, like 5 out of 10, the way this is set up is that you can build upon the 50, and in terms of the retake, okay, once you say were to take a second time, well, guess what? The 5 that are correct are already recorded as such, and you have an opportunity to build upon that half credit. So this is with a quick retake option, and where you have, if you have any incorrect problems, like re-entering or re-accessing the homework after the first submission or second submission, whatever, you're only going to have to retake the incorrect portions. Anything that you got correct is already logged in and recorded. And in the grade book, okay, the best score is going to be recorded. And once again, so just to access the homeworks, again, you just click on the 3 bars in the upper left hand section, click on assignments, and you got the list, and so you have Alex homework section R4 and factoring, again, which will be due on January the 20th. And we're looking at working with equations and identifying whether we have the result to be a conditional, contradiction, or identity. And we have, again, from page 68, we have for item number 24, okay, and we have this equation in terms of the variable n, whereupon we have 4 times the quantity of 3 minus 5n okay, and we have followed by the addition of 1, okay, and we have is equal to, and here we have negative 4n minus 8 minus 16n. So we are working with the variable n, and now for the first expression we have an n, we have the quantity of 3 minus 5n. So I can remove the parentheses upon distributing 4 over this difference. So you have 4 times 3 is 12. 4 over negative 5n, so this will be negative 20n. Again, we have plus 1. And we have is equal to. Now for the n terms, on the right hand side we have negative 4n minus 16n. So we're going to have a negative 20n and we have minus 8. And now for the left hand side we still have constants to combine, so we have 12 plus 1 is 13. So you have 13 minus 20n is equal to negative 20n minus 8. And looks like we have identical terms in the variable n. And if we combine these together, what's going to happen is that in combining the variable terms, which will occur by adding 20n to both sides, it's going to follow that we'll have the n terms to completely cancel. And so we're down to two numbers that will be said to equal each other when in fact they will not. Okay, so I have that 13 is said to be equal to -8. Okay, so this is going to be a false statement. And since there's nothing in n that can rectify this situation, okay, we're going to have no solution. And since we have a logical inconsistency with the output, okay, the category to which this type of problem is going to fall under, and that is going to be a contradiction. Okay, and so we have a contradiction in number 24. Now, in the case of what we have with number 26, okay, this time we're going from the letter N, okay, back to the letter X. And in this one, so we have -5 plus 3x equals 3 times the quantity of x minus 1 minus 2 So here we have -5 plus 3x. So these will not combine to any single term. And for what we have to the right, we have the distribution of 3 over the difference between x and 1. So this will become 3x minus 3, followed by the subtraction of 2. And we have in following through. Okay, so while we still have -5 plus 3x to the left, we're going to have making adjustments on the right hand side. We have 3x, and -3 and -2 will combine to -5. So we have like terms on opposite sides of the equation. And combining variable terms, we have once again those to be the same. And just like positive and -20n went out, well, we're going to have 3x and -3x to go out completely. So left standing will be numbers on each side that will be said to equal each other. And this time around we have -5 is equal to -5, and that is true. And in terms of x can be any real value. So, and since this is true, that means that for the solution, we can write this like write out all real numbers, or symbolically as the letter R, or in interval notation where we have those values of x running between negative and positive infinity. And anything that has an infinite number of solutions, or that will result as all real numbers in the solution. Okay, this is going to be another case of what is regarded as an identity. Now, in the case of number 28, and so we have here, and we got fractions in the coefficients. Now here we have 2/3 of y minus 5 is equal to 1/6 of y minus 4. Okay. And this one you can work out in different ways. Now you can combine the y terms with the fractional coefficients as they are, and just keep the fraction alongside the y at the present moment, and then undo at the last moments. That is one option. But if you want to go ahead and take care of the fractions, and because we're dealing with an equation, I can just go ahead and clear out the fractions. And I can just multiply everything in the equation by the least common denominator of 3 and 6. So this is going to be at 6. So if I'm looking at multiplying the whole equation by 6, now I'm going to be raising the coefficient absolute values, okay, but it's not going to change the solution in y. If it did, I will not be doing this. Okay, so for what we have here, so if I multiply everything in the equation by 6, this might be just a little bit more of a granular breakdown than what most would probably care for, but I just want to show you where the terms are going to arise in the next step. Okay, so for what we have here for 6 times 2/3 of y, you can cross multiply and reduce, but now we got 12/3 of y minus 30. Again, we have is equal to 6/6 of y minus 24. And if you see the next step already in advance, okay, so 6 times 2/3 will be 12/3. So this will become 4y minus 30. And 6/6 is 1, so you have y minus 24. Now I just did an incremental breakdown, but if you kind of went from here and just go ahead and multiply by 6, and if you can see the result mentally, multiplying by 6 and getting over here, that's fine. Okay, so we have with the terms, so you have 4y minus 30 equals y minus 24. Now we have like terms on opposite sides with 4y and y, as well as the numbers negative 30 and negative 24. And if I combine y terms, we're no longer going to have complete cancellation like what we had with the previous two exercises. So between 4y and y, if I start out canceling out either of the variable terms, normally I like to go out by taking away the smaller variable terms. So in this case, this is going to be at y. So I'm just going to take away y from both sides. Now we have in combining, so we have 4y minus y, this will become 3y. Now we have minus 30 is equal to negative 24. Now we have just a single y term, and here we have what's referred to as a two-step linear equation. And the strategy is going to be to isolate the y term, which we now have at 3y, and this will be upon adding 30. Whereupon we have 3y is equal to negative 24 plus 30, which will be 6. Okay, and so the first step we have adding 30. Second step will be just undoing the multiplication by the coefficient 3 upon dividing both sides by 3. And it's going to follow that for the missing value y. Y is going to be 6/3, which is going to be equal to 2. Okay, so we have for this equation that we started out with. Now, this is not the only way you could have combined the y terms and keeping the fractions But if you went ahead and took care of the fractions, just multiplying every term in the equation by 6 or any other common denominator, and then you reduce. Okay, so we have for the output, okay, we have y is equal to 2, and now this is going to be a conditional on the basis that we have a finite number of solutions. In this case, we have only one solution. So 2/3 of y minus 5 equals 1/6 of y minus 4. That would be true on the condition that we have the numerical value of y to be at 2. All right. Now, going back to what we have in the case of working with quadratic equations. And we have just with the next group, and we have on page 30. Okay, so you have a quadratic equation that is not presented in standard form. Okay, so you have y squared, okay, which is situated by itself, and we have set equal to 18 minus 7y. And if I were to put this in standard form, that is, have the y terms on one side, along with the constant, non-negligible constant on one side, and setting equal to 0. And again, arranging the terms in descending degree order. So I got y squared as the highest order term. So I can keep y squared where it is. But on the other hand, I can move the other terms over. So you can just move the 18 by subtracting and the 7y by adding. And so we're going to have in the rewrite, so we have y squared plus 7y minus 18 is equal to 0. And for what we have in the case of y squared, okay, now we have a factorable trinomial expression. Okay, so from y squared, we have y times y. And for negative 18, okay, factors of negative 18 whose sum or difference will be on the plus side at 7. Okay, so more weight will be given to the addition than to the subtraction. So we have y plus 9 on the side of addition, and we have on the side of subtracting, we have y minus 2. Okay, now we have, once again, initiating the process using the zero product property to determine just what values of y will make this equation ring true. Okay, so setting each of the formed factors to 0. Okay, so if I had that y plus 9 is equal to 0, again, solving for y, I'm going to take 9 away from both sides. So y plus 9 is equal to 0. That is going to be negative 9. As for y minus 2 is equal to 0, okay, so you have what value minus 2 is equal to 0. Now that's going to come out to y is equal to 2. And you can check the results here. And, okay, say if y is negative 9, now the square of negative 9 is a positive 81. Now the right-hand side, we have a negative 7 times negative 9 is a positive 63. If you add that to 18, this is also 81. And with 2, okay, we have 2 squared is 4. And we have 7 times 2 is 14, and 18 minus 14 is also going to end up at 4. So we have two solutions for y with negative 9 and positive 2. Right. Now, and let's say that for what we have in the case of still utilizing the zero product property. Now we have for number 34, okay, we have z squared is equal to 25z. And let me mention something. So you have z squared is equal to 25z. And now there might be a temptation to divide by z on both sides. But if you were to do this, okay, you're potentially leaving out a potential solution. Like your answer, if you're to divide both sides by z, you might have only half the solution. So if you notice, you have the highest order term in the variable we are solving for. So you have potentially up to 2 solutions. Like if I had like z cubed is equal to 5z, you might have potentially up to 3 solutions. Okay. And then looking at the possibility of there being 2 solutions. Okay, so we have a z squared equal to 25z. So I can make this into a quadratic equation in standard form. So I got z squared to the left, and I can move the 25z over by subtracting. So in standard form, I'm going to have z squared minus 25z is equal to 0. Okay, now this looks almost like a difference of squares. And if I had z squared minus 25 and no variable attached to the 25, it would factor to z plus and z minus 5. But since I have a z term in 25z, okay, so we have taking the greatest common factor, so this will be z. And factoring out, so you have z times the quantity of z minus 25. Again, we have equal to 0, so you have 2 factors here. And if I set equal to 0, we have automatically 1 solution for z, which is going to be 0. 0 squared is 0. 25 times 0 is 0. And then we have from the other factor, z minus 25. Setting this equal to 0, so we have the other solution to be 25. Like 25 squared is 25 times 25. So there'll be 2 solutions in z, whereupon we have the values at 0 as well as 25. Okay. All right. Now, number 35. Okay, now this one might run a little counterintuitively in terms of how to apply the zero product property. Now we have, for this one, we have a couple of binomial expressions in the variable m. Okay, whereupon we have the quantity of m plus 4 times that of m minus 5 is equal to negative 8. Okay, and for what we have here, okay, now it might be tempting to try to say m plus 4 as well as m minus 5 to negative 8, but you cannot apply the zero product property in this fashion. So one side of the equation must be 0 to be able to use the zero product property. Okay. So what does that mean here? That means we cannot use the binomials as they are in the variable m. And this is going to have a feeling or notion of sort of having to go around your elbow to get to your thumb. And it's somewhat a painstaking process, but here we're going to be looking at foiling out what we have here to be able to move the 8 over and then to factor once more. So you have the quantity of m plus 4 times that of m minus 5. So we have, again, have m times m, have m to the second. Outside product, can this be a negative 5m? Inside product we have a 4m, so you have negative 5m plus 4m. So this would be a negative m And 4 times negative 5 is negative 28. Correction, negative 20, and we have is equal to negative 8. And then we have reestablishing this quadratic equation and putting it into standard form. So we have, upon adding 8 to both sides, so we have m squared minus m. Negative 20 plus 8 is going to be negative 12. And we have is equal to 0. Yes. Yeah. Question?
How did you get the second negative then?
Okay. What I did, yeah, I'll mention. Okay. So if I were to FOIL out, okay, so you have m to the second. Okay, so you have your first. You have minus 5m. As your outside, and you have plus 4m. And then you have plus 4 times negative 5, so that's minus 20. So it's kind of like taking the FOIL. So kind of like with the geometric FOIL or the box method. And negative 5 times 4 is negative 20. So that's where that negative m came from. It came from taking the FOIL and combining that outside and the inside products. All right.
Okay, thank you.
You're welcome. Okay, so we have now that we have the constant adjusted from negative 8 to 0. Okay, we have now while m plus 4 and m minus 5 cannot be used as the combination in the zero product property route, we do have with the factors of m squared minus m minus 12. So we have on the side of addition we have 3, and on the side of subtraction we have minus 4. Okay, so we have m plus 3. Again, you have m squared minus 4m plus 3m is going to be negative m, and 3 times negative 4 is negative 12. And so we have taking each of the factors and setting to 0. Okay, so if m plus 3 is the 0 factor, we have m equal to negative 3. And as for m minus 4, okay, we have that m is equal to 4. And you can always go back and check if m is at negative 3. Negative 3 plus 4 is 1. And negative 3 minus 5 is negative 8. And you have like positive 1 times negative 8 comes out to negative 8. And we have with m at 4. 4 plus 4 is 8. 4 minus 5 is negative 1. And 8 times negative 1 comes out to negative 8. So both of those values of m will check out going back to the setup in the equation. Okay. All right. Okay. And we have in the next item, okay, and again, we're looking at solving by using the square root property of equality. Again, for the next exercises, okay, if you're at liberty to use any methodology, okay, you might be able to use something other than the square root property of equality. We're just taking what we have here and just going back. So again, if if x squared is equal to p, then that which represents the square of x, if we go out to first order, you have equal to plus or minus the square root of p, or itemizing, you have the square root of p as well as this additive inverse, which would be negative of the square root of p. Now, for what we have in the case of number 40, okay, so here we have looking at solving for the variable v, whereupon we have 6v squared minus 30 is equal to 0. And if we were to use the square root property of equality, now you can divide by 6, factor out 6, or we can just separate the terms. And we'll just separate at the start. So if I add 30 to both sides here, so I have that 6v squared is equal to 30. And again, just expressing in terms of v squared. So I'm going to undo the multiplication by 6 upon dividing both sides by 6. So I have 6v squared over 6, so this will be v squared. And 30 over 6 is 5. And so just taking what we have here. There we go. Okay, so you have, now we have x squared equal to p. So x squared is represented by v squared, p represented by 5. So if we go from v squared to v, and with p represented by 5, if we go to plus or minus the square root, so v is going to have plus or minus the square root of 5, and 5 is a prime number, and this cannot be reduced to an integer, nor can you reduce the radical. And so we have, with our solutions for v, we're going to have in exact terms. We have the square root of 5 as well as the negative of the square root of 5. And if you have like numerical answers, that'd be like a positive and negative 2 point, I guess, like positive negative 2.2 something. Okay, but in exact terms, they have square root of 5 as well as the negative of the square root of 5. All right. And let's say that now for number 41. Okay, this one a little bit tricky. This one looks like it's going to lead up to a radical reduction. And we have, in the case of 41, so you have the square of k plus 2 is equal to 28. And again, just kind of running on a parallel course to the square root property of equality. So we have like x squared is equal to p. Again, have x equal to plus or minus the square root of p. Okay, so here we have x represented by k plus 2. So if I were to lower from second to first order in k plus 2, okay, so you have plus or minus, okay, the square root of 28. Okay, now square root of 28, not a perfect square number, but it is one that you can reduce. And what I mean by this, okay, so you have, for 28, again, that in itself is not a perfect square number. There's no whole number times itself that will give you 28, but in the case of numbers, that will go into 28 and that are perfect squares. You have like a perfect squares. You have like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. And the highest perfect square number that will go into 28, okay, that is going to be the number 4. So, and extracting, okay, so you have the square root of 4 times 7, so it'll be the square root of 4 times the square root of 7. So the reduced radical form of the square root of 28, that will be 2 times, okay, the square root of 7 and just taking what we have now, we have k plus 2 is equal to plus or minus 2 times the square root of 7. And now we're looking at isolating k. Okay, and whatever constants I'm taking away from the left-hand side, okay, I'm going to situate this in front of the radical. Okay, so in this situation, I'm going to have k plus 2 minus 2. So I'm going to apply minus 2 to the left and a minus 2 to the right. So I'm going to get these to cancel out on the left. So we will have for k, if we express in compact terms, we have that k is equal to negative 2 plus or minus 2 times the square root of 7. And, or just like in Alex, if you itemize the solutions and leaving an exact form, we're going to have negative 2 plus 2 times the square root of 7, as well as negative 2 minus 2 times the square root of 7. And those will be your results. Okay, and just the format of the answers, like having the constant in front of the radical, it'd be kind of like like solutions from using the quadratic formula if you could not reduce the radical. Right, and now, and speaking of which, now we have regarding the quadratic formula, we have with the next items. Yes. Question?
Oh, wait, sorry.
All right. Now, in the case of taking what we have with the quadratic formula, again, you have just originating from the quadratic equation. Again, we had the standard form at ax squared plus bx plus c is equal to 0. Whereupon a does not equal to 0. And again, just for the same coefficients, now we have with the quadratic formula, okay, if I were to express this in terms of x equals, again, we have negative b plus or minus the square root b squared minus 4ac and we have all over 2a, and again, we don't want a 0 denominator, and once again, we have the a cannot be equal to 0. Okay, now for the next set of problems, and we have in the particular layout, and now I'm just going to kind of work these in a little different sequencing. Okay, so we have, say if I start out with what we have for number 64. Okay, so with 64. So I have a different letter with the n. So I have n squared plus 8n is equal to negative 3. So I have a quadratic equation, but I have it in terms of the letter n as opposed to the letter x. So I have n squared plus 8n is equal to negative 3. And again, if I put this in standard form, just moving the 3 over by adding. Okay, so we have n squared plus 8n plus 3 is equal to 0. And I'll just put a little emphasis on this since we're looking at identifying a, b, and c. Got like 1n squared plus 8n plus 3 is equal to 0. And just identifying what is going to represent a, b, and c. So you have a is equal to 1, b is equal to positive 8, and we have that c is equal to positive 3. Now again, we have a different letter to solve for in n. Okay, now this is the quadratic formula. And if we look at substituting directly, okay, so we have for negative b. Now b is at 8, so the opposite sign of b translates to negative 8. And we have plus or minus, okay, the square root. So we have with b squared, okay, so that is going to be 8 squared. And minus 4ac, so you have minus 4 times 1 times 3. And we have all over 2a, so that's going to be 2 times 1. Okay, so we have negative 8 plus or minus. Now 8 squared is 64. And negative 4 times 1 is negative 4. Negative 4 times 3 is negative 12. And we have all over 2. Now we're going to have a situation where radical reduction will be performed. Now we have the square root of 52 from taking the difference of, or taking the square root of the difference between 64 and 12. And just to kind of move over to the side here, so we have with the square root of 52. Okay. And the highest perfect square number divisible into 52, just like 28 earlier. Okay, that is only going to be 4. So for the square root of 52, that's going to be the square root of 4 times the square root of 13. And so this will go to 2 times, okay, the square root of 13. And so just translating, okay, what we have here. Okay, so you have negative 8 plus or minus 2 times the square root of 13 over 2. And now we have even numbered coefficients. So that means we can reduce this even further. And we can do this in various ways. Like I can just split what I have here apart. Have like negative 8 halves plus or minus 2 times the square root of 13 all over 2. And have 2 will go to negative 8, negative 4 times And what's going to happen here is that for 2 times the square root of 13 over 2, we have at least the 2's to cancel out. So we're going to have negative 4 plus or minus the square root of 13. And you can itemize where the solutions of n, again, will be negative 4 plus, as well as negative 4 minus the square root of 13. Okay, so just going back, okay, so I still use the quadratic formula, okay, in spite of having a different letter to solve for. And again, so A was at 1, B was at 8, C was at 3, so this is what I have with direct substitution. And b squared minus 4ac resulted as a constant that was not a perfect square, but was nonetheless a radical that could be reduced, whereupon the square root of 52 became 2 times the square root of 13. And then since we have even leading coefficients throughout, I was able to lower and simplify the solutions to n at negative 4 plus and negative 4 minus the square root of 13. Right. Now, and looking at, let's say for number 63, so again, I'm sort of taking a little bit of a reverse route. And normally, like a lot of problems would be regarded as advancing as you go from one problem number to the next, and that's not necessarily always the case. At least, I don't think it is. See, we have in the case of 63. Now we have with the letter M. So we have m squared plus 4m is equal to negative 2. Okay, so I'm going from the letter N to the letter M. And if I write this equation in standard form, so I'm going to have m squared plus 4m plus 2 is equal to 0. Now for this particular trinomial, okay, one might try to factor m squared to m and m, and the problem is that there are no integer factors of 2 that will add up to 4. Okay, the only integer factors would be like 1 and 2, negative 1 and negative 2, and the respective sums would be at 3 and negative 3, but not positive 4. So we have, again, just looking at reapplying the quadratic formula. So we had the leading coefficient a is going to be equal to 1. And we had the b is equal to 4. And we had that c is equal to 2. So we have with m, okay, so I have negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so you have a negative b, again, by direct substitution. So I have negative 4 plus or minus the square root. And for b squared, okay, so I have 4 squared. And I got minus 4. And AC, so I have times 1 times 2. And so you have over 2 times A, so that is going to be over 2 times 1. Okay, so after the direct substitution, okay, so I got 4 squared is at 16. Negative 4 times 1 is negative 4. In turn, negative 4 times 2 is negative 8. we have all over 2. Okay, so we have 16 minus 8 is going to be at 8. And kind of like 52 as well as 28. Okay, 8, not a perfect square number, but it is still one that can be reduced. And so we have with the square root of 8. Again, the highest perfect square divisible into 8. So that is going to be 4. And the square root of 8 becomes the square root of 4 times the square root of 2. So this is going to be 2 times, okay, the square root of 2. So we have negative 4 plus or minus, okay, 2 times the square root of 2, all over 2. And again, I can split up. We have negative 4 over 2 plus or minus 2 times the square root of 2 all over 2. And negative 4 halves is negative 2. And once again, we have leading coefficients between the numerator and denominator. We have the 2's out of the front. And we can get those to cancel. And we have the square root of 2 left over. So in compact form, we have for the solutions in M, we have negative 2 plus or minus the square root of 2. And you can also write this as negative 2 plus, as well as negative 2 minus the square root of 2. Okay. Now for number 60, again, it's kind of like moving backwards in a sense, but conceptually, I think the complexity is a little bit more going this route. Okay, so we're kind of adding a little muscle, so to speak, as we're going from one stage to the next, and sometimes they might doing the problems in reverse sequence. Now we have for number 60, we have 1/3 of x squared minus 7/6 is equal to 3/2 of x. Now, if you were to rewrite the terms like 1/3 of x squared minus 3/2 of x minus 7/6 is equal to 0, that's one way that you could present the quadratic equation in standard form. Well, let's say that if you don't care to deal with fractions, we can just go ahead and clear the 3, the 6, and the 2 out. Just multiplying everything out by the least common denominator, which we already have to be at 6. Okay. So if we multiply the equation by 6, okay, and you can look at just cross multiplication perspective or just the gradual reduction. Now from the cross multiplication, okay, you have like 3 will go into 6 2 times and have 2x squared, or see we have 6/3 of x squared still going to 2x squared. And you have minus, and you have 6 will go into 6 one time, and then you have 1 times 7 is 7, and with subtraction, you see we have negative 7. And just like 2 will go into 6 3 times, 3 times 3x becomes 9x, or 6 times 3 is 18 divided by 2. Still comes out to 9x. And so with the raised coefficients, okay, I can now translate what I have in standard form, and this time with the terms arranged such that we have in descending degree order. So now we're going to have 2x squared, moving the 9x over, we have negative 9x minus 7 is equal to 0. And then in terms of the setup here, and again, you could try using factoring by grouping, but there will be no combination in integers such you will have 2x times x and plus or minus factors of negative 7 whose. That's going to lead up to where the sum of the outside and the inside products will come out to negative 9x. Okay, so at least not in terms of integers. So if we go with the quadratic formula this time around, and now solving for the variable x, okay, so we have with a at 2, b at negative 9, c at negative 7. So we have a direct substitution. Negative b becomes the opposite sign of negative 9. Yeah, plus or minus the square root. Now b squared. So this will be the square of negative 9. And for minus 4ac, so you have minus 4 times 2 times negative 7. And we have all over 2a, so this will be all over 2 times 2. And we have in the follow through, so you have 9 plus or minus the square root. Okay, so here you had to be careful. Now we're working with negatives in the mix. And for negative 9 squared, okay, yeah, the square of negative 9, or negative 9 times negative 9, this will come out to 81. For the minus 4ac part, again, be careful. Negative 4 times 2 is negative 8. In turn, negative 8 times negative 7 becomes a positive 56. And 2 times 2 is going to be 4. And this time around, we have 9 plus or minus, and we have the square root of 137. Now 137 is going to be a rather high prime number. So 137 as a radical. 137 is not a perfect square number, and it is also a radical term that we cannot reduce. Okay, and so we have 9 plus or minus the square root of 137 over 4. And if you itemize, so we have 9 plus as well as 9 minus. Again, have 9 plus the square root of 137 over 4, as well as 9 minus the square root of 137, also over 4. All right, so just looking at what we have in sort of the next go round, and let me kind of mention something here. Say we have equations that involve rational expressions. And we'll say that we have here and let's see. Let's say we have 3 minus, and we'll say we have 3 over 3 plus 4 over so we have 3 plus 4 over x plus 1 is equal to, let me do it this way. I'll just take something, yeah. We'll say you have 3 plus 4 over x plus 1 is equal to 5 over x. Okay, so you're looking at solving for x, whereupon we have 3 plus 4 over x plus 1 is equal to 5 plus x. Now, let me mention some things here. Now, there was something from the other exercise where we had, at the start, restricted values. Now, whatever we have for x, okay, we cannot have zero-valued denominators. Okay, so just kind of as already as a precondition, now we have the x plus 1 cannot be 0, and the x cannot be equal to 0. So we have here, so we got the restrictions. X cannot be -1, and the x cannot be at 0. In other words, so you don't want 4 over -1 plus 1, which will be 4 over 0, and at the same token, we do not want 5 over 0. Okay, now for what we have here, we can clear out the fractions with the least common denominator. Okay, least common denominator, we're going to have the product of x and x plus 1. And in setting up, okay, what we have here, if we multiply all the terms out by x and x plus 1, so we have, just for starters, now we already have 3, we have times x times the quantity of x plus 1. Again, multiplying by the least common denominator. Okay, if you notice, okay, now we're not writing all the fractions in terms of least common denominator. We're going to clear out the denominators because we're dealing with an equation as opposed to combining fractions or terms together. Okay, so with what I have for the first, okay, I have 3x all over x plus 1. So this would be 3x squared plus 3x. And for the next, okay, you're going to have with 4 over x plus 1 times x plus 1. Now you're going to have x plus 1s to cancel out. So yeah, plus 4x. And for 5 over x times x times the quantity of x plus 1. Now we're going to have x's are going to cancel out, but we still have 5 times the quantity of x plus 1. And working with what we have now, so you got 3x squared, 3x plus 4x, okay, so this will become 7x. And for 5 over the quantity of x plus 1, so this is going to be 5x plus 5. I'm just going to write this again. I'm going to set this up as a quadratic equation. That is in standard form. So I'm going to move the 5x as well as the 5. And so for what we will have now, okay, so you have 3x squared, then you have 7x minus 5x, so this will become 2x. Okay, now we got 3x squared plus 2x minus 5 is equal to 0. Now I'm going to sort of bypass the factoring by grouping, but just in terms of factoring. Now for 3x squared, this is going to go to 3x and x. And for what we're going to have here for factors that we're going to have to be present. Okay, so we got in this one, so it looks like the way this is going to turn out. I'll do it. We do have just enough time on this in case you have 3x squared plus 2x minus 5. If I factor by grouping, so you got 3 times negative 5 is negative 15. Now looking for factors of negative 15 whose sum will be at positive 2, but right now it had 3 and negative 5. Now 3 and negative 5, okay, those will combine to negative 2. However, if I change the signs, so I have negative 3 times 5, that will be a positive 2. And we have upon splitting up, so we have 3x squared minus 3x plus 5x minus 5. And then we have with grouping, first two terms and the last two terms. Okay, so we have with the greatest common factors, 3x squared minus 3x, have greatest common factor is going to be at 3x. Into 3x squared minus 3x, so I'm going to have x minus 1. Bring down the plus. Greatest common factor of 5x minus 5, that will be 5. And we have times the quantity of x minus 1. So we're going to have, for this result, for the factorization, we'll have x minus 1, as well as the quantity of 3x plus 5. So this is what we have here. So for the factorization, just carrying over. So you have 3x plus 5. And the quantity of x minus 1 is equal to 0. And utilizing the zero product property, if I have the 3x plus 5 is equal to 0, so we have that 3x is equal to negative 5. And if I divide by 3, so we have that x is equal to negative 5/3. And we have with x minus 1 equal to 0. Now we're going to have an apparent solution with x equal to 1, and the preconditions have to be that x cannot be negative 1 or 0, and so these will check out. So we have x at negative 5/3, and also positive 1. Okay. And now there's another part which would be in the case of proportions, but just say for next time, let's go ahead and be looking into number 69, and we have with numbers 68, 74, and numbers 80 through 82. All right. Now let this be our stopping point. If anybody has questions, I'll stick around for the next few moments